Hi guys, welcome back. I hope this video finds you well. Today we are going to look at solving exponential and logarithmic equations. So there are 4 steps we want to solve or follow with solving these. The first one, we are going to look to isolate the exponential or the logarithmic function. We'll look at how to do that first. Once we do that, we're going to take the skills we worked on last week with rewriting. We are going to rewrite in a new form. This way we can undo the exponential to get into logarithmic form, or undo the logarithm to get into exponential form. We will want to simplify that. When we simplify, I want 4 decimal places. Now, some of the ones with powers, we won't have to worry about the number of decimal places when we convert to exponential form. But with logarithmic form, if that's where we have to convert to, 4 decimal places is what we ask. And then once we do that, it's just a matter of simply solving the rest of the equation for x. So we're going to pretend that this is basically like its own variable. This is what I want to get by itself. So when I look at it, it's like 4 times that plus 5. Well, going back to our older solving skills, I can say that problem on our paper says 125. Let me take this a second to correct that. So this is fine with the example I did upload. So 4 times this exponential plus 5 equals 125. Let's get rid of the 5 here. So that gives me now 4 times the exponential, so that's 5 to the 3x minus 2 is equal to 120. Okay? Now what I have to do is, if this had said 4x, we'd say, oh, let's divide by 4. Well, that's what's happening here again. Divide both sides by 4. And doing that, we get 5 to the 3x minus 2 is equal to, in this case, 30. So essentially it's saying 5 to some power is equal to 30. Well, we know 5 squared is 25. 5 cubed is 125. So to get 30, we're definitely going to have to utilize logarithms and our calculator. So that's what we're about to do. We're going to rewrite this as a logarithm. Since this has a base of 5, the log must also have a base of 5. So log base 5 of 30. So the log base of 5 is equal to the answer of 30. Sorry. The log base 5 of 30. So I took the base from the exponent and the answer here to create my log. Now that will equal what the exponent was here. 3x minus 2. Now log base 5 of 30 is not an easy number to calculate. It is a number that you will not know off the top of your head. You will need to use a calculator. So I am opening up my Desmos calculator, and we are going to take a look at this. So I'm going to go to function, go over to miscellaneous, and I want log base A. So I want to make that base 5, because that's what the base of this is. And then inside the parentheses, inside, I'm just going to type in 30. So that gives me 2.1132. I notice there's an 8 after the 2, so I'm going to round that up to 3. So all I did was type it into the calculator. So to simplify this now reads 3x minus 2 is equal to 2.1133. Now this is just a matter of solving for x. You've solved problems like this. This just happens to have a decimal, but we can work with that. So let's start with adding 2 to both sides. 2, not 3. So it's a minus 2. And that gives me 3x is equal to 4.1133. Finish by dividing both sides by 3. And we will get an answer already up here, nice and big. X is equal to, and again, this, just type it into your calculator, 4.1133 divided by 3. I hit enter, and I'm seeing my answer is 1.3711. So that is my answer. If I would plug this in, then simplify this whole side, you will get something very close to 125. I believe what I did earlier was 125.003. So again, with us rounding this answer, it does slightly affect it. This is a rounded answer, not an exact answer. But with going 4 decimal places, again, all answers should be 4 decimal places. That's what I'm asking of you guys. You will see that it does get a very close number to what it needs to be. So that's solving it when we have something with an exponent. Let's look at another example. This time it will have a logarithm. So for example 2, let me erase this. Example 2. Right one to write it. We have 3 times log base 4 of x, 5x minus 3, close parentheses, plus 8 is equal to 29. So in order to do this, again, I want to start with trying to isolate the log. What is inside the parentheses of the log, the 5x minus 3, we'll worry about later. We're just going to work on getting the plus 8 and the times 3 out of the way first. So if it was like 3x plus 8, we would go, oh, let's subtract 8 from both sides. And that would give me 3 times log base 4 of 5x minus 3 is equal to 21. Now that we have this, we could say, okay, if this said 3x, again, we would just divide by 3, so that's all we're doing here. Divide both sides by 3, so those cancel. Log base 4 of 5x minus 3 equals 7. Now it's a matter of doing our rewrite. We got the log isolated. I want to rewrite this as exponential form, or in exponential form. So since the log has a base of 4, what I'm going to say is that is now the base of my exponent. Since the whole log is equal to 7, that becomes the power of my exponential. So then that is going to be equal to what's left inside of the log, 5x minus 3. Now 4 to the 7th. Powers of 4 you might not recognize super fast off the top of your head. So what I'm going to do is quickly type that into the calculator as 4 to the 7th. And I get that is 6,384. So we'll just write that down. To simplify this, this is now 5x minus 3 equals 16,384. Now this number is big. This is just, hey, solve for x. So let's add 3 to both sides. I'm going to continue my work up here. So it will give me 5x is equal to 16,387. So dividing this by 5, again, this is probably something you just might want to quickly grab a calculator for, and that's okay. And that gives me x is equal to 1,277.4. So that is all we needed to do. Wait, did I type that in right? Sorry, I might miss. Oh, I missed a digit there. That would be why. Missed the one in front. Sorry, please ignore that. That was a typo in there. Should be 3,277.4. So here with this, yes. Here with this, we utilize the same idea. So the first thing we always want to do is isolate that log. That's what we did here. Then we rewrite in that new form. Once we rewrite in that form, we'll usually have something to simplify, either an exponential, some number to another power, or we'll have a log to simplify, log base b of a. And then you'll just finish solving from there. So they're really, some of these we see more than 4 steps, as we had these little steps in here. But there are really 4 steps to think through here. Some of them, though, when we're saying isolate and solve, you might be using a multi-step process you've learned before this. So give the problems that are assigned a try, and have a great day.